Minions, welcome to another exciting session, the beginning of a new chapter called Capacitors. So welcome aboard Minions. So this is Shreyas here, and today we are going to talk about capacitors. Now you would be surprised to know that capacitors has a big role to play in your telecommunication devices like the receiver, the transmitter, all your mobile phones, the radios, the Bluetooth, the Wi-Fi. So many circuits have capacitors inside them. Without capacitors, you would probably not have these radio transmissions and receiving signals happening out there. Also, the flash of your digital camera, maybe even in your mobile phone, makes use of capacitors. And I'm pretty sure many of you didn't know that. Without capacitor, you wouldn't have a flash in your camera. This sudden surge of power requires a lot of voltage. Now this high current, this high voltage cannot come, this sudden surge of charge cannot come through the battery. So what happens is that capacitor inside it stores that energy and discharges it. Something like this. This is a very simple schematic of how a capacitor stores the energy and discharges it. The circuit on the top charges the capacitor, and then when you discharge it, all the charge flows through the LED bulb or through the flash bulb, and that's how it gets utilized. And again, you can charge the capacitor and there is a sudden discharge of the charge through the bulb or through the LED. That's how capacitor is used in the flash of a camera. Very interesting. So this is how a capacitor looks like, by the way, and I'm pretty sure most of you would have seen capacitors on a printed circuit board, in a TV or in a radio or any opened up electrical or electronic appliance. Alright, so let's get going with capacitors with me, Shreyas, your master teacher for physics at Vedantu, and also the anchor of your channel on JEE Enthuse. So welcome aboard, guys. I have been teaching students, I have been coaching students for quite some time, and have produced some amazing results which I intend to do with you guys as well. So welcome aboard, and what a lovely start for today, guys. We started our day today morning at 8 o'clock. Yes, we conducted a Menti quiz and so many of you are there, and such a nice healthy competition we had. So glad to see so many of you back out here. Welcome Aarti, Feda, Selva, Ranjit, Kirito, Dinesh, Aishwarya, Saurav, Ankit, Sobna, Ufak, Ranjit, Uncharted 17S, Anish, Sneha, Satish Kumar. Oh my god, this family is just growing bigger and bigger, and I'm so glad that this family is growing bigger and bigger, and let's keep it growing, guys. Let's keep it very healthy. Our competition should be healthy. Let's take everyone together and let's march ahead. And I'm going to be your captain who is going to guide you through the rough seas and through all the turbulences that you're going to face in your life and through the journey before your competitive exams and even before probably the counseling that's going to happen. So tonight I'm going to go live on Instagram. So many of you might have already heard it and already seen the updates on Instagram. So guys, tonight I'm be going on Instagram live at 9 o'clock. This is my Instagram handle, Shreyas_Vedantu. So note it down, and if you have not yet followed me, go follow me over there. Only then you will be getting the updates and the notifications. I have already updated some really cool videos. You can check it out meanwhile when the lecture ends. So keep following me, keep getting more and more knowledge, and keep sharing all those videos as well. So welcome aboard, guys. Hello Mr. Vesh, hello Sneha, hello everyone, hello Avilash. Welcome aboard. So let's get going, and before we begin, let me also tell you that do not forget to hit the subscribe button down there, because unless you subscribe, remember, you're not going to get the new video notifications and you're not going to get the new updates, just like the ones you got today regarding the upcoming JEE and the board examination. So it's very important that you hit the subscribe button down there, and also do not forget that smash that like button down there. Guys, only if you smash that like button, I'm going to get that energy to conduct today's session. So go ahead, smash that like button out there, and then let's continue. Hello Kakni, welcome Yashasvi. Hello Pranuti. Nice to see all the minion pictures out there, and so many of you putting up statuses on Pandu and stuff like that. It's really cool. I keep checking them out. Okay, by the way, let's start with what is a capacitor and what exactly is a capacitor. I'm going to start from the basics, and you're going to see that I'm going to slowly increase the level till advanced. Okay, so we're going to start with mains level question, then advanced, then mains advanced, mains advanced. So there are going to be a combination of all kinds of questions today along with the theory. That's what flash series is all about. So don't worry, Ankit, even if you're 15th, I still love you. Okay, so don't worry. Even if you're last, I will still teach you and I'll still train you. It's not that I'm going to differentiate. So don't worry about it. All right. So let's begin. And here it comes. So what exactly is a capacitor? So capacitor is nothing but an energy storing device. Okay, it stores the energy. So it's an energy storing device. But in which form does it store the energy? So the energy is stored in the form of electrical potential energy. So it is stored in the form of electrical potential energy, and this is generally achieved by creating a potential difference across two conductors. How? Imagine you have a conductor like this, and imagine you have another conductor like this. Let's say you create a charge, or you put some charge on one device or one conductor, and you put some another charge on some another conductor or another device out there. Now imagine if you take a wire from this conductor passing through a bulb, okay, passing through a bulb to here. If you join it, immediately these positive charges or these negative charges are going to flow to nullify each other. So there is going to be a sudden flow of current. So the flow of current is going to be in this direction, and because of this, the bulb is going to obviously glow. So where did this light energy, this heat energy come from? That means there must be some energy stored before these two conductors were connected with each other. So that energy was basically the electrical potential energy between these two conductors. So I can very well say then that this device or these two pieces of conductor are nothing but a capacitor. So this is nothing but a capacitor. So any two conductors, you charge them, that's it, it forms a capacitor. As simple as that. I hope this is clear, and if you are understanding it, please let me know, and also smash the like button down there. All right. Yes, I hope this is clear. Okay. Now this is not like resistance. Resistance never stores energy. Resistors in fact lose that energy. They are bad, evil guys. Remember that. Okay, so why can't capacitor be used as a battery? Excellent question. The problem is, in a battery, whenever the chemical reaction happens, the potential difference across the terminals remains constant. So if you take a cell, even after some time, as long as the chemical reaction keeps on happening, an ideal battery should maintain that potential difference. That's one thing. But in case of capacitors, as these charges move, the potential difference between them keeps vanishing off. And you will see that the charge can be only stored for a small time, and not too much of charge can be stored on a capacitor, and the discharge really happens very quickly. So capacitors are generally used for quick charge and quick discharge of electrical currents. Understand that. So that's the problem. Okay, so that's the meaning of a capacitor, and this is how capacitors, by the way, look like. So if you spot these kind of things, these are nothing but capacitors. The value of those capacitances will be written on them. So this is how it looks like, in case you're wondering how it looks like. Okay, so they are very teeny weeny things, all right, in electrical circuits. So next thing up is capacitance. So how do I define capacitance, and what's the symbol for a capacitor? This is the symbol for a capacitor, and the capacitance has a symbol of C. There are two plates which are shown, all right, and the symbol for capacitance, guys, is C. So if you connect a capacitor across a voltage of V, so if you connect a capacitor across a voltage of V, then what happens is there will be charges which will be accumulating on it, and there will be a Q charge here and a minus Q charge over here. So Q is the charge stored on one side of the conductor, minus Q is the charge stored on the other conductor, which is separated by some distance. So Q and minus Q are the charges stored in the conductor. Remember, only when you connect these two terminals across some resistor, only then the charges will flow and they will nullify each other. Until then, those charges will stay there. If you just take a capacitor, it's charged, you can carry it in your pocket as long as you want, okay? The charges will not discharge anywhere unless you connect those terminals. Remember that. If those terminals touch, that's it. Those charges will nullify each other because they'll find a conducting path. So these things are related by this particular equation. Q is equal to CV. Very important equation. Q is the charge, C is the capacitance, V is the voltage. Remember, if you increase the voltage, okay, if you increase the voltage, Q will change, Q will increase. If you connect a bigger battery, more charge will be stored. C will depend on the size, the construction of that capacitor. So understand the capacitance, by the way, the unit of capacitance is nothing but farad, and 1 farad is when you take 1 coulomb of charge and you store it across 1 volt of potential difference. So when you apply 1 volt potential difference and the charge stored is 1 coulomb, then that capacitor has a capacitance of 1 farad. Now 1 farad is actually a huge capacitance because just by using 1 volt, it's very difficult geometrically and practically to store 1 coulomb of charge. 1 coulomb is a big charge. Generally the charges are in milli, micro, pico, 10 to the power minus 12, 10 to the power minus 9. So those are the ranges of coulombs which will be stored for normal voltages. So that's why you will see most of the times the capacitances will be in micro, milli or nanofarads. That's how it is. Alright. Yes, there will be opposite charges on the opposite plates. So when you should use a capacitor? When you want a sudden discharge, and there are many applications you will be learning in AC circuits where filters are there, LC oscillations, etc, etc. That's where you will be using capacitors. Okay, so depends Fida on the capacitance. Sometimes a battery, a very sasta, very cheap battery might have lower energy density than a very compact capacitor. So it depends on the manufacturer, the way in which it has been constructed. So you cannot really comment on that so easily. Okay, so very important things. So what is capacitance? What is the charge stored on it? Q is equal to CV. Remember this, write it down. Okay, now how do the charges get exactly stored? Where do these charges get stored? Not many people discuss this, not many books discuss this. So let me discuss that because questions come on this and you will see how important it is. Okay, yes, they will be attracting each other. In fact, we will be calculating the force of attraction between these two conductors also. Yes, there are questions on that, advanced type. You will be seeing it shortly. Now, these are the plates of a capacitor. Imagine these are two conducting plates. Okay, now these two conducting plates, if you see it from side view, that is from here, this is how they look. This is only the thickness of those plates. Remember, a plate has two surfaces, one this side and one this side. So since there are two plates, remember those Gauss law problems? There are 4 surfaces, 1, 2, 3, 4. So there are 4 surfaces over here. Now you take these plates and connect it to the positive terminal of the battery, plus V volts. So what is this plus V? It's connected to the positive side of the battery, and you take the other terminal, which is the negative terminal, let's say I call it 0 volts. So basically you have connected these plates across how much potential difference? Think about it, V volts. You have connected across V volts of potential difference. It could be from maybe a battery or something. Now what will happen? The charges which form up on the capacitor, you might be wondering, sir, where is this plus Q and where is this minus Q going to be? Wait a minute, that plus Q and minus Q will be here and here. This is where the charges are. This is where the charges are, guys. So understand, these charges are always on the inner surfaces of the capacitor. So this will be minus Q and the other one will be plus Q. Please remember, there is no charge over here. There is no charge on this side and there is no charge on this side as well. So can you guess, guys? There will be an electric field in this region, right? There will be an electric field only in this region, but the electric field outside will be 0. So the field outside will be 0, only the field inside will be something because of these charges. So everything that has to be stored is stored inside a capacitor. Nothing is there, nothing should be worried outside the capacitor. Nothing happens outside the capacitor, don't worry about it. Everything, the energy, the field, the forces, the charges, everything is inside the capacitor. Understand that, very, very important. So guys, remember one thing, if somebody asks you what is the charge stored on a capacitor, don't say, oh, Q is there, minus Q is there, so total will be 0. No. So the charge stored on a capacitor means how much is the magnitude of the charge on any one of the plate. It will be either Q or minus Q. Basically the mod of that, so it will be just Q. But if somebody asks you what is the total charge on both the plates of the capacitor, then the answer will be obviously 0. I hope this is clear. So understand that the total charge on the plates will be 0, but whenever questions ask you what is the charge on the capacitor, they only mean any one side's magnitude, that's all. Okay, be very careful. Excellent. Don't worry Ranjit, we are going to come to that formula and you will see some amazing questions and you will start appreciating this even more. So very, very important things, the charge is basically, and we have just told this Q is nothing but C times of V. What is V? The voltage. C is capacitance, remember that. Alright, gear up for a problem guys, some amazing questions coming up. So gear up for the questions. I hope your pens and papers are ready and your minds are open obviously. Alright, here it comes, the question in front of your screen. If the charge on a capacitor is increased, then its capacitance will increase, decrease or not be affected. Come on, tell me the answer correctly in the chat box. Increase, decrease or will not be affected. If the charge on a capacitor, if you keep on adding more and more charge, what will happen to the capacitance? Alright, I can see a lot of minions answering option A. Minions are answering option A, and let me tell you guys, the answer is wrong. Yes, you guys answered it wrong guys. The answer is it will not be affected. You will be like, what the hell? Sir, what the hell just happened? I just thought Q is equal to CV. So you might be thinking, oh, charge has increased, so capacitance will increase. Guys, be careful. Capacitance does not depend on how much charge you store. Capacitance depends on how you construct that capacitor. What is the size of the plates? What's the distance of the plates? What is the masala that you add? Matlab, the dielectric material between the plates, etc., etc. So it depends on the material, the geometry of that construction, not on anything else. So if you increase the charge, the voltage increases. Understand this capacitance depends on the geometry and the material inside the capacitor, nothing else. So the answer is not be affected. Yeah, no problem. Hota hai aise. Happens. That's why I conduct these kind of quizzes, so that you do not lose these marks in the examination. If this question would have come, or an identical question would have come, everybody would have lost marks. But all the JEE enthusiasts, all the minions out here are going to score those +4 marks, and they are going to boost their performance by at least some 400-500 ranks easily, just because they knew the answer. So excellent guys. So no problem. Now that you know, you are much ahead than those people who have not attended the session. So let's get going to the next question. Let's see how many of you get this. A capacitor is charged using a battery. Now the battery is disconnected. So hint for the problem, draw the diagram. Do not do it orally, you might most likely get a wrong answer. So draw it. So capacitor is charged using battery, disconnect the battery and again connect it. But when you connect it with the reversed polarity of the battery. The moment you connect it with the reverse polarity, some charge is going to flow through the battery. How much is that charge? That's the question. Let's see. So polarized means something which has polarity, Ankit. That's all. Like the sides are marked. This is positive, this is negative. That's all. All right, come on, come on, come on, come on, come on, come on. Let's see how many of you gave the correct answer. 0, CV by 2, CV or 2 CV. 0, no charge flow, CV by 2, CV or 2 CV. Very interesting, very interesting, very interesting. So let's see guys, the correct answer to this question. Guess what? Not many people have answered it. Yes, not many people have answered it. And the correct answer is option D. Now you'll be like, what the hell? Sir, what kind of horrible questions are you taking? Every time we think of something, your answers are always something else only. Guys, that's my specialty. I'll always choose some questions which I know will be asked in the final examination, because I know examiners are not going to give you all the usual questions. Yes, they will be there, but that is for the average population. You can get average marks, but if you want to score more than the average, then you have to crack those difficult questions out here. So guys, let's try to understand. Okay, so I've made some very cool visualization for all of you. So let's look at it part by part. Understand this. A capacitor is charged using a battery. This is a battery. Wow, such a cool looking battery. This is the capacitor. You charge it. So these will be the charges on the plates of the capacitor, obviously. Now, the battery is disconnected. The battery is disconnected, and what you do, you connect it with the reverse polarity. So the moment you reverse the polarity, what will happen to these plates? The charges will be also reversed. Think about it. This side will be negative, that side will be positive. Now, here comes the catch, guys. Think about it. This charge, plus charge, was plus CV. This negative charge was minus CV. We just saw, right? Q is equal to CV. So C is capacitance, V is the battery's voltage. Now, here, this side charge is minus CV, this side's charge is plus CV. Now just concentrate. This plate had, before this, plus CV of charge. This was before. Now, it has minus CV charge. So how much did the charge change by? How much did the charge change by? Think about it. 2 CV. Yes, it changed by 2 CV, not 0. Because from from plus 1, it has gone to minus 1. So the charge has decreased by 2 CV. Understood this concept? Understood this concept? So the charge has decreased by 2 CV. So that means, where did that charge go? That charge would have gone through the battery and it has accumulated here. So how much charge flows? The charge which flows will be 2 CV. And think about it. This 2 CV charge, alright, on this negative plate, added it. So that minus 1 became plus 1. Look at that. This minus CV became plus CV because you added 2 CV to this minus CV charge to make it plus CV. That's what has happened when you connect this battery. So the charge that flows through the battery is plus 2 CV. That's the answer. What a question, guys. I hope you guys have understood this question. Now these kind of questions are common. Sometimes they tell you, instead of one battery, there were 2 batteries in reverse polarity. Or sometimes they tell you one battery is removed and then you attach 2 batteries in the same direction. So you just need to draw before and after diagram. If you do not draw before and after diagram, you will most likely make a mistake. So remember that. So please draw the before and after diagram, analyze it practically, you will get it. Okay, chalo, let's go to the next thing. Now before going to the next thing, let me also tell you guys the crash course which is running for, all the 12th standard and the dropper students. So I know a lot of students want to get their doubts solved. They want some test series. So if you guys are interested in some test series, and it's not just test series and that's it, the answers are given. No, there is a discussion which happens, like a proper session which happens to clear all your doubts. There are 10 full syllabus test series, 10 part syllabus test series, and also there are special sessions for cracking JEE examinations, and also there are 120 live sessions, guys, for all the chapters, physics, chemistry, maths, whatever. And there is unlimited doubt solving within the app from our subject experts from morning till night. So you can ask all your doubts, get it solved, unlimited doubts, there is no limit on that. And best part is it's a two-way platform where the teacher, class teacher, whatever is there inside the classroom. You can interact not just with the teacher, with also the fellow students and stuff like that in the Telegram group or when the chat is open, and with the class teachers, with the doubt panel. So many amazing features. You should go check it out. All right. And all these things are at just 10,000 rupees, but 20% off running. So that's why you will get it for only 8,000 rupees. So use this coupon code SHCC. That's it. Everything is sorted in life. You can get 20% off, and you can also share this coupon code along with the description link to your friends or your relatives who are interested to join the Vedantu crash course. All right. So do not hesitate to join, guys, because some amazing teachers are teaching over there. So you are going to love it. And a lot of my students have already joined, and they are giving me really good feedback. That's why I'm recommending it to you. All right. So let's get going. Sir, in Vedantu many classes is not coming for 10. VK channel, maybe you should contact your Sam. Maybe he will be able to help. I'm not the right person right now to help you out on the YouTube. All right. Okay. So if there are two batteries, basically, Kirito, what will happen is, just think about it again. If there are two batteries, the charge on this will be 2 CV and this will be minus 2 CV. So just think, earlier the charge was plus CV, now it has become minus 2 CV. So look at the change. From plus CV, it has become minus 2 CV. So the change will be 3 CV. So that will be the answer. Okay. So Richu, I'm not taking the NEET crash course, but some amazing teachers like me only are taking the crash course. Let me tell you that. Okay, Richu. All right. Now look at the next concept which is coming up on your screen. How much is the energy stored inside a capacitor? Let's talk about it. Now we just spoke about how when you connect a battery to a capacitor and the battery's potential difference is V, then there is a field which is set up because of the charges, and there is some energy which is stored inside the battery. So the energy stored within the capacitor. The energy stored inside a capacitor is in the form of electrical energy. So this is electrical potential energy in the field inside the capacitor. This is very important. Where is the energy stored? And this energy stored has a symbol U. The formula is half C V square. C is capacitance, V is the potential difference. If you don't like that, sometimes other formulas are also going to be helpful to you. Half Q square by C. So both are equivalent formulas, guys. You have to remember both the formulas. How do you get it? Simple. Just put Q is equal to CV. If you put Q is equal to CV, it will become C square V square. C square and C, one of the C will get cancelled and you will get CV square. So this can be obtained by using Q is equal to CV. Do not forget that. Yes. I hope this is clear. So crash course will be basically the entire chapter's main concepts. Think of it like something like flash series only. All right. More of like doubt solving will also be there along with problems. Something like flash course only. Okay. Great. So remember this formula, guys. Let's do a question which is going to come up on your screen. Very important question for JEE NEET, Olympiads, everything. It's very important question. Not many people get it. But I have already done the first part of the question with you. A capacitor is charged using the battery. Same question. The battery is disconnected and connected with reverse polarity. What is the change in the electrical energy stored, and what is the work done by the battery? Same question, just that I have asked you what is the work done by the battery and what is the energy stored change inside the capacitor. So let's do this step by step. Again, this was the battery connected to the capacitor and it has charged it. You disconnect, reverse the polarity and connect it again. This is what happens. We have just seen this question. Now let me first of all mark the charges over here. This is minus CV, this is plus CV, this is plus CV, and this is minus CV. This battery's voltage is V. Okay, and we just saw that when you disconnect and connect it with reverse polarity, the charge which flows through the battery ठीक है, the charge which flows is nothing but 2CV. Now let's do it step by step. Just think about it. What is the initial potential energy stored inside the capacitor? Well, the capacitance is C, voltage is V, so half CV square. What is the final potential energy stored in the capacitor? Oh, the battery is the same, polarities never matter, so it is half CV square. So then, what is the difference? The change in the potential energy will be 0. I hope this part is very, very clear and very obvious. So the first answer is obviously 0 joules or whatever, 0 units. No change in the potential energy. The polarities never matter for the energy, remember that. Now, you will be like, okay, if there is no change in the potential energy, then battery is useless, battery would not have done work. That is completely wrong. You'll be like, sir, why? Guys, think carefully. Charge has flown through the battery. If charge flows through the battery, what is there across a battery? Potential difference. And what happens when you take a charge across a potential difference? Energy changes. Okay, so now probably you are understanding what is happening. You are taking a charge of 2CV from the lower terminal to the higher terminal, lower potential to higher potential. So what are you doing? You are doing work. You as in the battery. You'll be like, sir, why will battery do work? From where is it getting the energy? Guys, the battery has chemical energy stored inside it. So the chemical reaction will do the work in moving these charges. That's the job of a battery, in fact. So understand the work done by a battery. Very important formula. Note this down. The charge which flows, okay, into the voltage of that battery. Very, very important formula. The charge which flows into voltage. In fact, this was also there in electrostatics. Q into V. Q delta V is delta U. It's nothing but electrostatics formula, nothing else. Correct, Ranjit. And Q is how much? 2CV. How much is the voltage of the battery? It is V. So the answer will be 2CV square. Now this is the work done by the battery. Now there is a very interesting, fascinating concept out here. You will be like, okay, now I understood, sir, what is happening. But there is a small catch, guys. And what is that catch? Here is the thing. The battery has done some work, but none of them went to change the energy of the capacitor. None of it went to change the energy of the capacitor. So where did the battery's work go? Battery did some work. It should have changed the energy of the capacitor, but it didn't. Think about it. Where did it go, guys? Where did it go? Can you answer this question? Can you answer this question? Think about it. Yes, you could have written it down in terms of Q also, and Q is V itself. Moving, yes, that movement has been there, but it has to go somewhere. Okay, the charges have got that energy. Okay, fine. The work done by the battery went in giving potential energy to the charges. Where did those charges energy go? It didn't go in potential energy. It has gone in heat. Correct, Aishwarya. Yes, it has gone in heat. Yes, the internal resistance. Yes, Saurav. Yes, correct. So it has gone in internal energy. So there will be some small resistance of that wire, and that wire will get heated up. So that will be the remaining energy, heat. So if a question is asked, this question was asked. A battery is there connected to capacitor. The battery's polarity is reversed. Find the heat developed. You know what kids did? They found out, initial energy half CV square, final energy half CV square, change 0. So heat nothing. Wrong, 0, negative marks. Guys, the battery did work. So that battery's work went as heat. So if the question is how much is the heat, the answer to this question is, understand this part, 2CV square. 2CV square. Hello Jinson, welcome to the gang. You are now a minion, and you can become a member by hitting the subscribe button and join in. Welcome. Okay, I hope this is very, very clear, guys. So the heat has been produced because the battery did work on those charges, and those charges eventually settled down. So where did the charges lose those energies? They lost in the form of heat in the small resistances out there. Okay, very important, very important. Okay, so yes, very good tricky question. Okay, now what are the important pointers you are going to remember? First thing, use formula. What is it? Come on guys, revise with me. Use formula, half CV square or Q square by C. 2C, sorry. Alright, that's one formula. Second formula, work done by battery. What is the work done by battery? I hope you have written it down in your notes that you have been making. Work done by battery, charge which flows into potential difference of that battery. Second formula. Third important formula, this red line, what I have written. Work by battery is delta U plus heat. This is very important equation. This is going to revolutionize the way you interpret energy problems in capacitor. So very important. Write this formula down. So what happens if there is theoretically no resistance, then the charges will keep oscillating back and forth. That will come under a separate section called as LC oscillations, which you will study in AC circuits. So the charges never go away, and it keeps on oscillating back and forth. But here we know the charges have settled down. That's why. Okay, very good, very good. So let's get going to the next question, guys. Similar concept, but a very different way of solving. Very different value that you will get. Again, there is a capacitor. It is charged using a battery. Okay, what is the work done by the battery? What is the change in the electrical energy stored in the capacitor? And where did the remaining energy go? Let's do this question. So first of all, the moment you charge this battery, there will be some charges accumulating on the plates of the capacitor. So first thing, come on guys, let's do this. What are the charges stored over here? So over here, plus Q will be plus CV, and this side it will be minus CV. Potential difference is V. In this charging process, let's see if you can answer it. Earlier there were no charges on the plates. When you connect the battery, some charges flow. How much charge do you think has flown in this battery to charge the capacitor? Come on guys, answer the question. How much charge has flown through the battery in charging the capacitor? Think about it. Earlier there was no charge. 0, 0. Think about it. 0 and 0. Now it is minus CV and plus CV. So how much charge did you take from here and put it over here? Think about it. No, it's not 0, Jumna. Think about it. It is CV. You took out CV from here and put it over here. So earlier there were 0 and 0. So once you take CV from here, it will become negative, and that plus CV you put it here, so it will become plus CV on this side. Okay, very good. So the charge which flows, very important, always show this, always show this for solving these type of problems. How much charge flows through the circuit. Okay, great. Next what? Let's do this. What is the work done by the battery? I just told you work done by the battery is the charge which flows multiplied by potential of the battery. So what is the charge which flows? CV. What is the battery's voltage? V. So it will become CV square. That's one answer. Work done by the battery. Next, the change in the potential energy stored in the capacitor, guys. It will be final minus initial. Final will be half CV square. Initial was 0 because it was not charged only. So this answer is nothing but just half CV square. Now last thing, what did I tell you? Equation. Remember which equation? Work done by battery goes in delta U plus heat. What is the work done by the battery? The work done by the battery, I just told you, it is CV square. What is delta U? Delta U is half CV square. So guys, what is the heat developed in the circuit? Think about it. What will be the heat? CV square minus half CV square, which will be half CV square. So guys, the poor battery did CV square work. The poor battery did CV square work, but only half CV square gets stored in the capacitor. Half of the energy is lost in heat. Very interesting. Very interesting. I hope you guys understood this concept now. Before this, some of you might have seen this in your regular coaching or elsewhere, and it would have looked very difficult, but I hope I have made it very simple for all of you. Yes, it is like income tax. At least income tax is 30%. So here the income tax is 50%. Very bad country. Okay. Yes. Correct. Let's get going to the next question. By the way, I have a beautiful question for all of you. Is there a way to charge the capacitor without any energy loss? Now don't say, sir, I will use a wire which is perfectly conducting. No, that's not the answer. Even with a wire which has some resistance, you can charge the capacitor with minimal energy loss. How can you do that? Post the answer in the comment box below. I'll be reading all your answers. Okay, so post the answer in the comment box below. Okay, now let's see the different types of capacitor, guys. I hope you guys are ready and all enthused. Okay, can't be able anything. What happened, Saurav? What happened? Are you 11th standard or 12th standard? Yes, so let's talk about the types of capacitors. What did I just tell you? The capacitance depends on geometry, the shape, size, and basically the materials filled inside. So let's see what the different types of capacitors we have in JEE. Please understand, there are other types of capacitors also, but we do not study them in JEE syllabus or NEET syllabus or board syllabus. Alright, so you guys are ready. Now, the first type of capacitor that we have in JEE syllabus is called as a parallel plate capacitor. So what do? Take two plates, put it parallel, that's it, parallel plate capacitor. So simple. You can also make it at home. So two plates, charge them, and there will be electric field, which is something which we have been seeing all this while. So the charges over here, all right, are positive. On the other side it's negative, and there is electric field between them. So that's nothing but a parallel plate capacitor. The capacitance of such a capacitor is given by epsilon naught A by D. What is it? Epsilon naught A by D. If you fill some masala, this is like a sandwich. Imagine this is like bread. You add some jam, you add some mayo, you add some cucumber, you add some tomatoes, you add some dielectric. So if you add some masala over there, then that masala's dielectric constant should come over here. Yes, so that K will come over here. That K is, remember the dielectric constant? I have told you this in electrostatics. So that K will come over there. Understood, guys? Understood? Yes, you make parallel bread sandwiches daily. Very good one. All right, yo. Let's get going. Now, remember this formula, by the way. Remember one more formula that you have to remember. What is the field between them? What is the field between them? Now, pay attention to the field, guys. Okay, I'm erasing this part because I hope you would have written it down. Now, pay attention carefully pay attention. Very, very important. Lot of people get confused over here. There is positive charge here. This positive charge will give rise to electric field in both directions, correct? Electric field in both directions. What will be the electric field due to the positive charge? It will be sigma by 2 epsilon naught. Remember, I have shown you this formula, guys. A sheet which is charged of density sigma, correct? So the field goes both ways, and the field is charge density by 2 epsilon naught. Now what is the charge density? Well, that's Q by 2, Q by A into 2 epsilon naught. Sigma is charge per unit area. That's what I have got. That's E plus. So the field due to this positive plate will go both sides. I know you might be thinking, sir, just now you told outside the capacitor the field is 0. Now what nonsense is this? Why have you shown field? Don't worry, I'm going to explain. Now this negative charge is also going to create a field, but the field will be towards the negative charge. So there will be a field coming like this, E minus, and the value of E minus should be also Q by A into 2 epsilon naught, guys. Everyone clear? Everyone clear? Yes, it is constant. It's constant. It is uniform field. So it is not dependent on the distance. It's uniform field because of a plate. Now, think guys, if you are outside, what will happen? This E minus and E plus, what will happen? They will cancel each other. So outside the field will be 0. I hope you can see that. Outside the field is 0. Very clearly, red is going up, green is going down. Red is coming down, green is going up. So outside the field is 0. But here inside, what is happening? Inside it is not 0. In fact, the net field inside is E plus plus E minus. Both are adding. Did you see that? How cool is that? And that's why the answer is Q by A epsilon naught. Very important. Very important. So this is the field. This is the field inside a capacitor. Remember this formula. You will need it a lot. You will need it a lot. Understood, everyone? Such a very simple thing, but many people fail to explain or understand this. Yes, so field inside. Remember that masala has field, but outside that sandwich the field is 0. Okay? Excellent. Let's solve some questions. Let's see how many of you get this. First question coming up on your screens now. Which of the following will double the capacitance of a parallel plate capacitor having some area and distance? Multiple options can be correct. Check the options. Which of the following do you think can double the capacitance? Come on guys, quickly start answering. Yes, Ibraj, come on, join in. Thank you, VK channel. Come on, Deva Harsha. Think there are more options which could be correct. Come on, I want every minion out here to start posting the answer. Come on, minions. Saurabh says all are correct. Good evening, Vasudev. Join in, start answering. Come on. All right, a lot of you are saying AD, some of you are saying ACD. Sneha said AB, I think. Saurabh is saying ACD, and Shreya is also saying ACD. So the correct answer is ACD. Yes, A, C and D. Now you think how? Because I just told you capacitance is epsilon naught A by D. So if you make the area 4 times, distance twice, so 4 by 2 will be 2. So A option will be correct. So 4 divided by 2 is 2. So it will be 2 times. This will be 1 divided by 2. No, this will not be twice. This one will be 1 divided by 1 by 2, which will make it 2. Because that, distance between the plates is below. So when you half it, the 2 goes on the top. And this one is 1 by 2 by 1 by 4, which is going to make it 2. That's it. So A, C and D are the correct options. Very simple. If you know the formula, play around with the values. That's it. You will get the answer. Okay. Chalo. Let's get going to the next question. This is very, very important question. Now many people are going to fail over here. Okay. Now you see why I'm taking these questions, and you will truly start appreciating these kind of problems. See guys, what is the force of attraction between these plates of capacitor? The question is, what is the force of attraction between the plates? Now, I know what you guys are going to think. You are going to think like, sir, I know the field, I know the charge, what else is there? The charge is Q minus Q. So the force is charge, remember, charge multiplied by field. This is the formula for the force. So the force should be Q. I just now calculated the field. How much was it? Q by, oh, that 2 was not there. Q by A epsilon naught, isn't it? So you will be like, ha sir, I know what to do now. It will be q square by a epsilon naught. But this is not the correct answer. No, this is not the correct answer. Why is this not the correct answer? Like, sir, what have we done wrong? Everything you gave, we just used it. Yes, you used it. But think, what is the field? This field is, whatever you have written down, is because of both the plates. Guys, this field is not because of this plate or this plate. This is because of this and this plate. So to find the force on this charge, you just need the field of only this charge, right? So when you have to calculate the force, you calculate it like this, charge into field. But this field is not the field because of this charge. It is a field because of other charges. I hope this is very clear in your head. Yes, remember this field because of others or other charges. That's how it is. If you have a charge and if there is a field, whose field is this? Is it this charge's field? Obviously no. It's a field due to other charges. Remember that. So hence I have over calculated the answer. So hence understand the field should be only because of one plate, which is 2. So there is a 2 factor which will come over here. So it is half of what you would expect. Yes, sig q square by 2a epsilon naught. That's the final answer. I hope this is clear, everyone. Has everyone understood this question? All right, all right, all right. Yes, very good, Mohammad. Excelente, excelente. Now, see, first ball I put a spin, next ball I'm going to put a yorker, next ball I'm going to put a bouncer, next ball I'm going to put a swing. Every question is going to be different. Observe this. Where did it go? Here it is. What is the force on an electron between the plates of a parallel plate capacitor? What is the force acting between them? Now you will be like, sir, now I know what to do. Sir, force is charge multiplied by field due to others. So the force on the electron should be the charge of the electron, which is E, multiplied by the field. So what should I put over here? Should I put Q by A epsilon naught or 2A epsilon naught? What do you think I should put over here? Should I put 2 or should I not put 2? Should I put it or not? What do you think, guys? Ankit, maybe not this Sunday, maybe some other day, okay? Alright guys, no, you will not put 2. Think why? When you talk about the electron, the field will be because of both the plates, right? The field is because of both the plates. See, when you talked about force on one plate, when the force was on the plate itself, then you will not count the field of the plate. But now the question is not force on the plate. The question is force on some other third charge. So the total field will come. So it will be just A epsilon naught. There is no 2 in the answer. Understand? Hence the answer will be QE by A epsilon naught. So that's the force. Very important. I hope this is clear. I hope this is clear, guys. Okay? The previous question, that 2 factor was there. Here that 2 factor is not there. Yes. What a question, guys. Such beautiful questions. Next question. Before that, I need to tell you the next part of the theory. Cylindrical capacitor. Come on, guys. Going well? Thank God, Saurav. You scared me. Acha. So, cylindrical capacitor. Cylindrical capacitor means take 2 cylinders, charge the inner cylinder with one charge, charge the outer cylinder with other charge. The field will be from inside to outside. Something like this. So the reddish one is the inner cylinder, the outer one is the bluish one, and you can see inner cylinder has some radius A, outer one has some radius B, and the length of the cylinder or the height of the cylinder is L, and you will see the field will be those orange lines coming out over there, and the capacitance is given by 2 pi epsilon naught ln. What is ln? Log to the base e. If you don't like this ln, guys, it's okay. I will write it as log b by a, but this is to the base e. Remember that. This is the formula which you should remember. It's logarithms to the base e. Bigger by small. Don't remember, sir, was it a by b? Was it a b by... don't keep it like that. Bigger by smaller. That's all you should remember. And last thing, the field. See this field? There is some field, but this field, is it uniform? No. Why? Because the field lines are going away from each other. So the field intensity weakens as you go away. And you'll be like, sir, what is the field then? Here is the answer for the field. The field value is given by 1 upon 2 pi epsilon naught lambda by r. You'll be like, sir, what the hell is this lambda? Guys, it's the same lambda which we have seen in electrostatics, charge density per unit length. So this is charge by the length. So basically it is Q by L. So the charge which is there on the cylinder upon the length of the cylinder, that's the charge per unit length. So that's lambda. So you can see as R increases, the denominator increases, the field reduces. So this is the formula. In fact, this was also the field formula for an infinitely long wire, if you remember it correctly. Yes? Clear? I will give you a question now. Come on, the question is going to pop out on your screens. I hope you have written down all these questions, all these formulas, important pointers, etc. So the field varies inversely to R. Remember that. Alright, so let's get going, and here it comes. Find the energy stored in a capacitor which is cylindrical of inner radius R, outer radius 2R, length 9 centimeter and connected to a battery of 10 volts. Let's see how many of you get the answer. Come on guys, start doing it. How much energy is stored in a capacitor? Cylindrical one. And those of you who are clueless, no problem, I'll help you out. So I'll keep solving it parallelly, and others who want to keep trying it can keep trying it now. So the electrical energy stored will be half C into V square. Now the value of the capacitance I just told you is 2 pi epsilon naught by ln, alright, big radius which is 2R divided by small radius into V square, of course. Now this 2 cancels and you shall have pi epsilon naught V square by ln 2, I believe. That's what you are going to get the energy as. Now let's start substituting things, but before we do that, let's do one small thing over here. 1 upon 4 pi epsilon naught. Remember, the value of 1 upon 4 pi epsilon naught was 9 into 10 to the power 9 approximately. So hence, think about it, pi epsilon naught, correct? So pi epsilon naught will be nothing but 1 upon 4 multiplied by 9 multiplied by 10 to the power 9. So that is what pi epsilon naught is going to be, and let's use this. U will be equal to that value, that crazy number, 1 upon 4 into 9 into 10 to the power 9. Then ln2 is downstairs, so I'll just keep ln2 as it is. And V square is nothing but, oh, I forgot one thing. There was a length term, my bad, there was a length term. So I just need to put that length out here, else I'll get a wrong answer. So 2 pi epsilon naught length. I'm not sure whether I missed that length term in the previous slide, guys. In case by mistake, if I missed that length term in the previous slide, please add that length. Yes, please add that length in the previous formula if by mistake I have missed that length term out there. All right. So what will happen? So remember, capacitance is 2 pi epsilon naught L by ln B by A. So remember that? Yes. Oh, I missed it. My bad, guys. So sorry. So please add that length term. I think I just missed it. It just slipped my mind. All right. So what will happen? So just put that length on the top. So the length is 9 centimeters. So that means 9 into 10 to the power minus 2 will come there. And also voltage is there. The voltage is 10. So 10 square. That's it. So now solve this and see what do you get. 9 cancels. 10 to the power minus 2, 10 to the power 2 cancels. And you shall have 1 upon, check this out, 4 ln 2 into 10 to the power minus 9. So you can just leave it like that. 1 upon 4 ln 2. This 10 to the power minus 9 is nano. So nanojoules. This much amount of energy is stored. Okay, I hope this is clear. So very small energy, it's hardly anything, but this much energy stored and you can calculate it. Okay, I hope this is clear. Shall we go ahead? Shall we proceed ahead to the next type of capacitor, guys? I hope you guys are ready. Yes, you can check the options and based on that you can decide whether you want to solve it further or you want to leave it. If the options are in ln, leave it like this. If the options are in decimals, then you need to solve it further by putting ln2's value as 0.673 or something. Okay, so let's get going ahead. Next type of capacitor is spherical capacitor. So spherical capacitor, and there is another type, fourth type also I'm going to give you. Yes, so spherical capacitor, quickly let's start writing down. There is an inner shell which is charged and there is an outer shell which has opposite charge. The field goes from inside to outside or outside to inside depending on which side is positive, which side is negative. The capacitance, let me not try and make a mistake out here. So 4 pi epsilon naught should be there on the top. You should have 1 by something upon 1 by something, and here should be a smaller number. The smaller number is A, and so that 1 by A becomes big and the bigger number is B. So 1 by B becomes small. So the reason why I put it this way is because I want to make it big minus small so that it remains positive. So this is the formula for the capacitance. And the field, guys, the field is like a point charge. I hope you remember the field due to a point charge. How is it? Q 1 upon 4 pi epsilon naught. It's like a shell, guys. Shell's formula everybody knows. Q by r square. I hope you can see that in this situation the field is inversely related to r. So in parallel plate capacitor, field is constant. In cylindrical, it is inversely proportional to r. In spherical, it is inversely proportional to r square. Yes, you can call it now, I don't know what you guys made. For cylindrical, you can think of rolls. So roll, yeah, and this one probably pani puri inside a pani puri or momo inside a momo. I don't know, it could be anything. Yes, Ankit, why not? You can create a 1 farad capacitor, but it will be slightly difficult to create it, but you can. Yes, momos inside pani puri. Wow, interesting combination. So here comes the next and the last type. Now you'll be like, sir, what kind of capacitor is this? Where is the next plate? Where is the other plate? There is only one conducting sphere. The other sphere or shell is not there. The other shell is infinity itself. Yes, the other shell is infinity. So it's exactly the spherical capacitor, but I will call it as the isolated sphere. Now you know what is the advantage of doing this? Observe. The capacitance of a capacitor is 1 upon 4 pi epsilon naught, 1 upon something minus 1 upon something. Here you always had that smaller radius. In this case, let's say the radius is r, so it will be 1 by r, and the other plate is at infinity. The other plate is at infinity. So what should I put the radius? Infinity. What is 1 by infinity? 0. So it will become 4 pi epsilon naught 1 by r minus 0. And take that r upstairs. It will become 4 pi epsilon naught r. That's it. So very beautiful, cute looking formula, guys. you should remember it. You should remember it. Very simple formula. Alright? Yes, so this is a laddu. Motichur ka laddu. That's it. This is the last type of capacitor. So we have seen sandwiches, we have seen rolls, we have seen momos inside laddus, laddus inside momos, momos inside panipuris, panipuris inside momos, and lastly we saw an isolated laddu. I hope this is clear. Oh, gulab jamun. Oh, don't remind me of gulab jamun. Yaar, Science Priya. I had, I think, some 5 to 6 gulab jamuns today. It was crazy. I went to a engagement ceremony and had some crazy gulab jamuns. It was amazing, beautiful, amazing. What texture, what sweetness, yaar, matlab, and garma garam. It was too good it was. Okay, chalo, let's solve a question. Now let's see this question. A sphere of radius r is given a charge q. It is given a charge q. Find the electrical energy of that sphere. So a sphere is given a charge. Find the energy of the sphere. Now you might be like, sir, how do you do it? How do you do it? Because think about it. On a sphere, there are charges everywhere. Now this charge will have potential energy with this charge. This charge will have potential energy with this charge. This charge will have potential energy with this charge. This charge will have potential energy with this charge. This charge will have potential energy with this. This will have 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 with this and so on and so forth. How many terms will be there? So many terms. Are you going to sit and add? Like, no sir, but we will integrate. Do you have that patience? Obviously no. So what do we do? Don't worry. Shreyas Sir is here. So what is Shreyas Sir going to do? What? Oh, that earthing is just given IC time pass. Don't worry about it. It's just to show that you can use the energy of the this conductor, and all the charges will flow if you connect it to the earth. So there is some energy stored inside this device. You can completely discharge that energy by connecting it to the earth. So don't worry about it. So what to do? Guys, isn't this a capacitor? Which type of capacitor is it? Is it a sandwich? Is it a roll? Is it a pani puri inside a momo? Or is it a laddu? Ranjit, you can do that if you know this problem. It's a gulab jamun. Yes, correct, Science Priya. It's a laddu. Correct. So what is the capacitance of a laddu? It is 4 pi epsilon naught r. So what is the energy stored? Half q square by c. So just substitute q square by c. C is 4 pi epsilon naught r. So this will be q square by 8 pi epsilon naught r. That is the answer. Done. That's the energy stored. How many lines? I have used so many lines, but you don't even need so many lines. Did I do integration? No. Did I do any addition, subtraction? No. Did I do any complicated maths? No. Just treat that gulab jamun as a capacitor. Your problems in life is solved. Yes, such a laddu question actually. So let's get going ahead. That's how you calculate the energy stored inside a charged sphere, guys. Now let's do another interesting question. And so many people do it by such ridiculous methods, guys. But you will see how we are going to solve this. Are you guys up? Are you guys up? Alright, come on, let's do this. The inner sphere is given charge Q. The outer shell is given charge 2Q. If they are connected, find the energy lost. This is common kind of question. Now you'll be like, sir, how to solve this? Don't worry. First, let's do it part by part. How? Don't even connect it first. First think what is happening. So guys, it was given that inner sphere is given how much charge? Q charge. So the inner sphere has been given Q charge. So if there is Q charge here, what will be there on the inner surface of the outer shell? Obviously induced charges, and we all have done this type of questions in Gauss's law. So it will be minus Q. But the outer shell has a total charge of 2Q. So use charge conservation. So what should be there on the outer periphery? There should be a positive charge. But how much should be the positive charge, guys? Come on. It should be totally adding up to 2Q. Think about it. Totally adding up to 2q. How much should it be? Answer in the chat box. Answer in the chat box. Come on guys, don't get deviated. Focus. No, not 4. 3. Vemula, correct. Very good, DM. Very good. Yes, correct. It will be 3q, guys, because 3 minus 1 is 2. So there is a plus 3q charge. I hope you understood the charge distribution. Now, guys, think and tell me, if you connect this part to this part, what will happen? What will happen, guys? If you connect these 2 points, this will behave like one single conductor. And when you have a conducting device, no matter how many cavities are there, where are the charges? Are the charges on the cavity? No. Where are they? On the outermost surfaces. So what will happen? All these charges will flow out and it will come on the outside. Yes, completely on the surface. All these charges will quickly move away and they will come on the surface. So that's what is going to happen. So initially there was field inside the shells, but the moment you connect a wire and understand, the field only remains outside. There is no field inside the shells. I hope this is clear. Everyone. So I'll just probably show those charges out here. So there were charges like this, and there were charges outside as well. And in this situation, the charges are only outside. There is nothing inside. So guys, can you identify a capacitor over here? There is a capacitor here. In fact, there are 2 capacitors. I'll tell you which are the 2 capacitors. One capacitor is this to this. Look at that. There is a capacitor. Inner radius R, outer radius 3R. That normal spherical capacitor. And there is another capacitor. Which is that another capacitor? This outer one, where the outer field is. So there are 2 capacitors. One is gulab jamun, other one is pani puri with that momo. So 2 capacitors are there. Yes, isolated and spherical. Now when you connect it, which capacitor goes away? I think this capacitor which is inside goes away. But the outer one obviously still has that 3q charge, because that q and 2q will completely add up to give 3q. So understand, guys, what is happening. Guys. Think about it. So the inner shells or the inner capacitor's energy is going away. So where will that energy go? Lost. It is lost in the form of heat or whatever. So this lost form of energy is basically the energy lost from the inner capacitor. And how much energy did it lose? It is nothing but half q square by c. Now what is that c, guys? The c for a capacitance, for a spherical capacitance. What is it? 4 pi epsilon naught upon 1 by something minus 1 by something. So if you don't like to write it over here, no problems. Write it slightly on the top. So it will be 1 by something minus 1 by something. What is that something? So it will be r and 3r. That's it. So now solve this. This will become q square. There will be 8 pi epsilon naught. 3 minus 1, 2. So it will become 2 divided by 3r. That 2 gets cancelled with this 8 out here. So it will become q square, and 3, and there is 4 over here. So it will be 12 pi epsilon naught, and r, of course. I think that should be the answer. Just check it out. I hope we have not missed anything. Yes. So this is how you are supposed to solve. So you might not even realize that this is a question on capacitors. People think this is a question on Gauss's law or electricity. But if you notice, I have converted this problem into a capacitor problem to easily solve it. and you can solve this question if you have practiced these kind of questions. Very, very important, guys. Very, very important. Okay? Excelente, excelente. Now, I was planning to do this question, but I'm not sure should I do this easy question or not. I'll give the hints. I'll give you this question as homework. So this question is for homework, guys. A capacitor is charged till 10 volts using a battery, and then you disconnect that battery. So initially what is happening? You charge a capacitor to 10 volts. The capacitance is 1 microfarad, and then you disconnect that battery, and now this capacitor is connected to another capacitor which is not charged, and the capacitance is 4 microfarad. Okay, now when you connect this capacitor to another uncharged capacitor, I think the charges are going to flow. The question is, what are the new charges on each capacitor? Yes, so this is your homework. I've showed you the simulation. This is your hint, guys. I mean, come on, I can't give more hints than this. Observe it carefully. You charge a capacitor, disconnect the battery, then take uncharged capacitor, take this capacitor, connect it, the charges will redistribute. So find the new charges on the capacitor. That's it. I hope this is clear. So do this for homework. Last thing for today, energy density. If you find how much energy is there per unit volume, where this energy will be half q square by c, and this volume, let's say for a parallel plate, will be area into the distance, because that's the volume of the cuboid. That is called as the electrical energy density. Rho stands for density, U stands for that electrical potential energy wala density, potential energy, sorry. So rho U comes out to be half epsilon naught, okay, E square. This is the formula, and you are supposed to know this formula. Very important formula. Electrical energy density. Electrical energy density, half epsilon naught E square. Very important. You can do this very easily. Substitute the value of C. I mean, if you do that, you will easily get it. Put the value of C as epsilon naught A by D and all that. Substitute it and you will get it. It's not that difficult. Okay, very, very simple. Half epsilon naught E square. Now, there is a simple question on that, but before that, let me also showcase our stars for today who have posted the answers in the previous videos. Science Priya, 17S, Selva, Ranjit, and so many others who have posted the answers for the questions, guys. So all those people who are going to post the answers, I'm going to display their names and their comments out here. So do not forget to post the answers in the comments, not in the live chat below. Okay, so be careful. So this is your second homework question. So there is a charge, you are at a distance r. What will be the electrical energy density proportional to? What power of r will it be proportional to? What power of r will it be proportional to? So that's your question, guys. Alright, so that's your question. So note it down. Do not forget. I hope you have noted it down. You can also take a screenshot of the same. Anyways, all these things will also come up in your session PDF. Okay, and I hope all the dropper and the 12 students have also listened to the crash course, which is going to start every Monday with 120 live sessions, 20 test series, and also two-way interaction along with doubts from morning till evening. Unlimited doubts you can solve with special tip sessions for JEE Mains and Advanced 2021. So the crash course, I think, alright, I don't know why 7,000 is mentioned, but just check the price, guys. It might vary sometimes. I don't know why 7,000 is written. Just check the price. It should be 8,000 rupees. The coupon code, by the way, is SHCC. And all the answers along with the solutions will be posted on the official Telegram group. So do not forget to check it out. It's there in the description box below. Okay. And see you guys in 1 hour. Hardly 1 hour, less than 1 hour. In 40 minutes. Where are you going to see me? On Instagram Live. Are you guys ready to see me on Instagram Live? Are you guys excited? Yes or no? Alright. Okay. So see you on Instagram in around 40 minutes. Bye bye, take care. This was Shreyas here, your master teacher for physics at Vedantu.